Hello friends, in this video we will talk about recursion. Recursion is a programming method which is used to solve some particular type of problem which has a repetition in terms of when we divide those problems into the smaller problems. So you can consider this as a divide and rule type of problem, but a very one particular segment of that, because here we are dividing the problems into the smaller problem and solving those. But the catch is the problems are not different. When we in divide and rule type of problems, what we do, we divide the problem to the smaller problems, and those sub problems can be of different types. But in case of recursion, the problem are of the same nature but of the reduced size. So let's see an example and try to understand what are the different types of problem that we can solve in recursion, and how to divide those problems into the smaller pieces. Again, there is a very specific method to think about those problems. These type of problems are very tough when you start on recursion type of programs, but with practice it can be mastered. And I will talk basically a method which will make the recursion type of problems very cakewalk for you. So in recursion we have a bigger problem, right, and we will divide this problem into the smaller problems. In basic divide and rule, the problems are of, we can divide the problem into the smaller problems, but their nature can be different, right? These are the different problems. But in case of recursion, what happens? We have a problem and then we will divide it into the smaller problem and then further smaller, and we will keep going till the problem become a very small. And here we will try to return based on some base condition. Many students face problem in identifying what should be the base condition and how to divide these problems. So let's see first with a very basic example. So let's take a problem where you have to calculate the sum of numbers from 1 to n. Okay, this will be your signature of function. Now what you have to do, you have to do this, right? So to solve this problem, one approach you can think, which is a iterative process. Run a for loop from I equal to 1 to n. Okay, and from there you can take some initialize to 0, and on each time what you will do, sum plus whatever the I, or it is starting from 1, so let's start with 1, right? At the end you will get the sum. Now this approach is called iterative process. Why iterative? Because we are iterating on all the numbers, right? Now let's see the same problem, which is very small, simple, to solve using the recursion. Can we solve that? If I say, instead of finding the sum, if I find the sum of n minus 1, okay, and then I will add n, right? So we have divided this big problem into the smaller problem where sum of n minus 1 is found. Now you may say n minus 1 is still, how will you solve this problem? The same approach, we will divide this further of n minus 2 and then plus whatever the n was in previous thing, right? So this n minus 1, and similarly if I divide this n minus 2 type of problem into n minus 3, then plus n minus 2. This way we will keep dividing this problem till what point? Base condition will be 1, right? Because we have to find sum equal to 1. So if here, so the till we will keep going, and if sum of, so basically we will say this thing, if n equal to 1, or we can make it 0 also for this problem, but let's, because we have to find sum of from 1, so let's keep the same. If n equal to 1, then return just n, right? Now when we have solved this smaller problem, we can solve this problem, then we can solve this, then we can solve this, and the response of this sub problem we will get from the downside, right? This problem will be solved. So whatever is written, let's say we have capital S as the sum of this, then we can just add this and return the sum. So if you want to write this in a program form, what will be the code? Sum of n, right? Now for this, what we will do, I'm using Python syntax, but you can use any language. This is this will be applicable to all the language, because recursion is a programming technique of programming, right? Not any specific language. So here sum n, and then we can say if n equal to 1, then return n. Else what you have to return, you can guess, sum of n minus 1 plus n, right? That will be just code, and this much of code can solve all the things, and this approach is called basically recursive approach, right? This one, and this is the iterative approach. Memory requirement is almost 0, except on the stack we will add some addresses of this function call. I'll talk on that in some other video, how the stack unbinding happens and how the stack wind basically when we call the recursion function, what are the challenges with recursion functions. But if the base condition and this division of the sub problem goes haywire, it's not correct, then your function may go in an infinite loop and it will basically crash your program. So I hope you got the idea what is the recursion and how to divide the recursion into the smaller problems and what is the base condition. Now let's talk about how to decide what should be the base condition. So base condition will always be the small problem, the smallest problem that you can say. In another video we will talk about a problem about, let's say, reversing the linked list using the this recursive approach. So there we will see, okay, the examples of the base condition, but in this concept video we can say the base condition will always be the smallest sub problem that you can think of for that major problem, right? And your sub problems, you have to decide how you are dividing the problems and making it the smaller problems. It's a very simple approach. Only thing that you have to master is how to divide the problem and how to identify your base condition, and that's it. But that's it requires some practice, because it is a way of thinking to divide the problems into smaller problem. And I think you can solve most of the problems which are solved using the iteration can be solved using the recursion. Some problems are easy to think in iterative method, but some are easy to think in recursive than in iterative. So you might have heard about the problem, the Tower of Hanoi, where you used to have basically 3 towers, right? And one of the tower has some disk, right? And let's say this is a tower, and here we have some few disks, and the condition is these disks are lying in decreasing order of their radius. So the bottom one is the highest, and here at the top we have lowest. Now these problems, now you have to transfer these disks to the, let's say this is the tower A, tower B and tower C. You have to transfer all the disks to tower C, but the catch is you can't put a disk which is having the higher radius on top of the smaller radius basically disk. Let's see an example. Let's say we have 3 disks only, right? Now if you put this top one at this location, right, and then first, second, third. Now the second disk you can put here, but this will break our constant, right? Because this higher radius disk is kept at top of the smaller radius disk, and this problem is called Tower of Hanoi. You can Google search it. It's a very famous problem. So idea is like, okay, you put the first 2 disks here and then put third one here and then the second one and then the first one on this, right, to transfer all the disks from A to C. But this is not possible, right, because it is breaking that condition. So what could be the approach? With 3 problems, 3 basically the disks, you can solve manually. Let's try. What if I put let's say this is 1 2 3. If first I transfer 1 here and then let's say 2 here, right, and then again 1 here. So let's say I put this way 1 and 2 and then put 1 here, then 2 here, right, then 1 on top of it, right, sorry, on top of it, right, and then 3 here, then 1 here, and then 2 here, and then 1 here. So I hope this is a little confusing, I know, but if you try on your copy and pen, you have to just, the problem statement is basically you have to transfer all these 3 disks to C. The catch, the constraint is you can't put like basically the disk which is having the higher diameter or higher radius on top of the smaller one. Okay, you try. I think these will be the step which you can solve for 3. It will be fun and puzzle for you, but let's try this if there are 64 towers or these disks on tower A. Then it becomes very challenging, right, for a human to transfer here and there. But through recursion, I think we can do that. So will you accept this challenge and solve this Tower of Hanoi problem, and let me know in the comment section your code. You have to think about the base condition. You have to think how you can transfer those things, those disks basically, right? Would you like to take a few minutes and pause this video? I'll discuss the solution here, but first I would suggest you pause this video, think on your own, and then continue watching this video. So let's continue. I have redrawn this Tower of Hanoi. This is tower A, tower B and tower C, having these 64 blocks, these disks of different radius, added at with decreasing order of their radius. Now the problem I am iterating again. You have to move all these disks to third disk, given that each disk, the no disk having higher radius can be added on top of the smaller radius one, like this. If disk has a smaller, and then this should not be the case. Always the case should be like this. Okay. So I have written the program, but to go through that problem, let's first discuss about the approach, that how we will solve that problem. As in recursion, you have to first divide the problem, right? What if I say the condition is lying on the highest one, right? This one cannot be added and on top of anything else, right? Others can be like shuffled, But this, for moving this to this, you first have to move all the rest of the disk to some middle one, right? So we will, if I say the problem in this way, move all the n minus 1, the top n minus 1 to B first, and then we will move the highest disk to this, right? Now this disk become a kind of fixed, right? Because this is the highest radius. So on top of it we can add anything. Now if I reverse the problem, again you move all these disks to these basically n minus 1 to A, right, with n minus 1 disks at the top, and B again will be empty, and C at the top we have this the highest disk, right? If I again redo this, then problem will be reduced for us, and the reduction is one disk, right? We have make the last disk to the right tower. So if you see this code, what we have done here, n is our total number, here basically we have 64, A is the first tower, B is the middle tower which we can use as a spare one, and C is the final tower. So what we have done, if n equal to 0, just return, because there is nothing to move. If TOH is stand for Tower of Hanoi, right? This is the function name that I have given. Again I have written in Python syntax, but you can use any language. So it is just focus on the concept. In Tower of Hanoi, we are moving these n minus disks. To which particular tower? B. So from A to B, right? This we have to move this to this, using this as a spare one. So here what we are saying, move all the n minus 1 disk from A to B first to attain this type of is the state, so that we at the last we can move this particular basically disk to C. So what we are doing, we are moving all the disks from n minus 1 disk from A to B using C as a spare one, and after this is done, we can do our final step for that particular movement of the highest disk one, and we have printed that step, and n is the index, nth basically the disk, moving from A to C, right? So this is just a print statement, so that at the end, like we can get, okay, what are the first step that has been taken. So once this step is done, then what we are doing again, we are moving all the disks which were placed in these n minus 1 to A, right? Moving all the disks from from B to A, the original tower, using C as a spare one, right? So with this, what we have achieved, we have moved the highest diameter or radius disk to the right place, and make the problem again same, reducing the number of disks on that original problem. So what we have done, we have reduced the problem size with one disk and saying the base condition n equal to 0. So if you identify this base condition correctly and these steps, how we have reduced the problem, I think you will get the idea and the crux or the recursion. Thinking the problem in a reduced manner is the toughest part of the recursion. If you follow that, if you got that idea and base condition, then I think you can master recursion and you can crack any type of problems using recursion. So how is your confidence about the recursion now? Please let me know in the comment section. And if you like this video, please share with your friends and like this video so that it can reach to other students as well. Subscribe to this channel. This will help this channel to grow and reach other potential students who require this type of knowledge. With this note, this is BK from Maneka signing off.